Let's answer this question before us. It is taken from VCAR 2019, Northern Hemisphere, paper 1, question 5. So it says the population of birds feeds at two different locations, A and B, on an island. The change in percentage of the birds at each location from year to year can be determined from the transition matrix T shown below. Here it is. In 2018, 55% of the birds fed at location B. Find the percentage of birds that are expected to feed at location A in 2021. You might like to pause this video and see if you can think about how it is you would approach it. All right. So what you're going to do here is you're going to treat 2018 as your starting point. So 2018 here, let's write here, this is going to be my starting point. So S subscript 0. So that means I now want to find the percentage of birds that are expected to feed at location A in 2021. Well, 2021 is therefore going to be, if I'm starting at 2018 at S0, that means S1 would be 2019, S2 would be 2020, and then S3 would be 2021. So this here will be S3. So I want to figure out what S3 is going to be. So I'm going to take my transition matrix, raise it to the power of 3, and then multiply it by my initial state there. Okay, so now let's do that. So I'm going to come over here, and then I'm going to come here. Now, T cubed, I'm going to go 0.8, 0.2, 0.4, 0.6. And now, what is my initial? Well, 55% of the birds feed at location B. So what I'm going to do is I'm going to say, there are 55 birds at location B, which means there are 45 birds at location A. So I'm kind of treating this 55% percentage as just like a whole number there. And then you need to make sure, the most important bit, make sure you've raised that to the power of 3, your transition matrix, and we're going to figure out what this is going to be equal to. So let's come over here. And I'm going to come there. I'm going to get myself a nice 2x2 matrix. It's going to be 0.8, 0.2, 0.6, and 0.4. I then am going to raise that to the power of 3. And then I'm going to multiply that by another matrix, this matrix over here. And it's going to be 45 and 55. Okay, so that means what I'm going to end up with here is 65.28, 34.72. Therefore, if it's asking me find the amount of birds in location B, A, that means I'm going to end up with 65.28% at location A. Location A. Because I'm after the amount fed in location A. So that's going to be 65.28 in location A. So that right there is my answer. If you're kind of a bit confused about, why did I make this 55 and maybe not change it to 0.55, you could do that as well. So let me just show you an alternative way of thinking about this. So you don't have to write this down if you don't want to. But if you just want to see it done another way, what you could have done is done exactly the same with your transition. So you can't change anything with your transition matrix here. Raise it to the power of 3. But if you're like, this is 55%, what you could do is say, well, this is 0.55 and this is 0.45. So that's the only difference there. And if you did that instead, well, now when we come up here, I'm just making that point, hit enter. And now what you're left with when you do this is 0.6528, 0.3472. And then you need to know that, 0.6528 is the same as 65.28%, because it says find the percentage of the birds that are expected. So that might be the only place where people get a little tripped up in thinking about what it means, to go from percentage to decimals and treating them as whole numbers. But hopefully that makes sense in how you would approach this question.